Hello. In the previous videos, we learned that after firing alpha particles at the gold foil, at the nitrogen gas, and God knows what else, we now know that a nucleus consists of protons and neutrons. So both the protons and neutrons are called nucleons since they make up the nucleus. So the electrons, since they are not found in the nucleus, they are not nucleons. In chemistry, an element refers to atoms with the same number of protons, right? So in nuclear physics, we have something similar. A nuclide refers to nuclei with the same number of protons and neutrons. So basically, a nuclide is a family of nuclei with the same nucleus composition. To denote the composition of a nucleus, we use the nuclide notation, also known as the AZ notation, which looks like this. It's easier to explain with an example. So for example, this one here. Firstly, He here refers to the helium element, just like in chemistry. Next, the A in the AZ notation is called the atomic number. It's also called the charge number. It's also called the proton number. The proton number is probably the most intuitive name. So the 2 here means 2 protons. But sometimes I think charge number is the more accurate name, because later you'll see that for electrons, we actually put the number -1 here. Now let's talk about the Z in the AZ notation. It's called the mass number. But I think the more useful name is the nucleon number. So the number 4 here simply means that there are 4 nucleons in this nuclide. I find the mass number a bit misleading because the number 4 here doesn't mean that helium nucleus has the mass of 4U. U is the unified atomic mass, yeah? Remember? A proton is not exactly 1U, a neutron is also not exactly 1U. And in fact, a proton and a neutron don't even have the same mass. That's why I think the nucleon number is a more accurate name. So if there are 4 nucleons, but only 2 protons, what does that mean? It means there are 2 neutrons. So when you see this notation, you know that we are talking about the helium-4 nuclide, which consists of 2 protons, 2 coming from the proton number here, and 2 neutrons. These 2 coming from the nucleon number, minusing the proton number. Quite often you also see the shorthand notation here, helium-4. So compared to this one is missing the information of the proton number. But I suppose if you know it's helium, you should know that it has 2 protons. So in that case, He4 is actually a more convenient notation than this one. At least it's easier to type into a computer. Okay, let's practice the AZ notation on this one. So firstly, which element are we talking about? If you know your periodic table very well, then you know that the element with 92 protons is actually uranium. As for the number of neutrons, you got to take the nucleon number minus the proton number, so 143. So we are talking about the uranium-235, which has 92 protons and 143 neutrons. Now I told you just now that the AZ notation is used to denote the composition of a nucleus, but sometimes you use it to denote even the electrons. So can you identify these 4 particles here? So this one has 1 nucleon but no proton. So this guy must be the neutron. This one here has 1 nucleon and 1 proton. So this must be the proton. As for this one, it has no nucleon, but it has a charge of -1e. That makes it an electron. As for this one, it has no nucleon, but the charge of +1e. This is actually the positron. Now the positron is actually not in your syllabus. It's actually the antiparticle of the electron. Now let's talk about isotopes. Basically, isotopes refer to nuclei with the same number of protons but different number of nucleons. So these 4 nuclei here, all of them have 6 protons. They are all carbon atoms. Carbon-11, carbon-12, carbon-13 and carbon-14. All of them have 6 protons but different number of neutrons. So we say that these 4 nuclides are isotopes of carbon. Now as far as the chemistry is concerned, all isotopes have the exact same chemistry. For example, when carbon undergoes combustion with O2 to form CO2, it doesn't matter whether this carbon is carbon-11, carbon-12, carbon-13 or carbon-14. They undergo the exact same chemical reaction. But physics-wise, of course, they are different since they have different masses. For example, if you pass these 4 isotopes through a magnetic field, they'll undergo different circular motion simply because they have different masses and therefore different centripetal acceleration. Okay, to round up, let's make sure we know the difference between nucleons, nucleus, nuclei, nuclide, and isotopes. So firstly, how many nucleons do you see here? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 nucleons. So remember, a nucleon can refer to a proton or a neutron. Next, nucleus and nuclei are the same thing, except that nucleus is singular, nuclei is plural. So this is one nucleus, this is another nucleus. Altogether, I see 5 nuclei here. Now, how many types of nuclides do you see here? 4 types, right? There's a hydrogen 1, hydrogen 2, hydrogen 3, and helium-4. These 2 nuclei are the same nuclide because they have the same nuclear composition. Now, what about isotopes? These 3 are isotopes of hydrogen because all 3 of them have 1 proton but different numbers of neutrons. Alright, that's all. Ta-ta!